The first requirement of logistic regression is complete information. In order to proceed with a logistic regression model, we must have complete information, or relatively complete information. Data has to represent all combinations of the predictors in order to get a good idea of what the trends are. So consider this very simple example. If we want to predict the likelihood of donation using gender and whether someone was a previous donor, each of those two variables has two settings. Let's say gender 1 is a woman and gender 0 is a man. And then we have whether someone's a previous donor with a 0 meaning never donated before and a 1 meaning that they have. We want to use these two variables. So we're going to need all possible combinations of each of those two things. You have to have data for both genders, and you have to have data for whether someone's a previous donor on both sides. I have to have people that have not donated before and people that have in order to get a trend about the differences in gender or the differences in whether someone has donated before or not. In addition, I need the combinations of those things. I need to see men who have donated before and who haven't, and I need to see women who have donated before and who haven't. Otherwise, if I say don't have men who have donated before, how will I know what to predict if I haven't ever seen that situation? So if I don't know what a man's odds are of donating, how can I expect the model to know this? So I need to have collected data representing the entire possibility space. So all genders, all previous donors, and have all combinations so that I can expect the model to do a good job when it sees new cases pop up. But that's the simplest example. So let's extend this to represent the problem we're studying with the donations. We want to be able to predict the likelihood of a donation using age and income and employment status and dependent status. So now you can see how challenging the problem really is. I need to have all ages represented, not necessarily infants and 1-year-olds and 2-year-olds, for example, but all ages that I'm interested in. So let's say I'm interested in everyone from age 18 to 80. Then I need to have ages that are representative of that spectrum. I don't necessarily have to have a 78 and a 79-year-old, but I need to have most ages represented here. And that isn't the complete information problem. The complete information problem is that I don't just need all the ages, I need all ages at all income levels and all employment statuses and all number of dependents. So you can see how this problem gets more and more complicated as I add predictors to the model. But basically I'm saying I need a real good representation of each population that I'm studying. I need young people who have just graduated from college at all income levels. I need older people who have families at all income levels. I need to make sure that I am accurately representing the population I'm studying by including lots of different kinds of measurements. So the training data for the model must include a variety of ages, incomes, employment, and dependence combinations. If, for example, I only have elderly people who do not work, then I won't accurately be able to predict any other type of situation. So I have to make sure that I'm randomly sampling the population when I collect the data so that I don't have any biases in my sample, like only having elderly people who do not work. Now, the interesting thing about complete information is that R is not going to generate an error if we don't have complete information. We're just going to have a bad model. In the next section about prediction, we'll be able to tell more about detecting when we have a bad model. But for now, just know that we really need to make sure that we have a good representative sample. Now, how do I tell if I do? Well, this problem is incredibly complicated. It's very hard to tell if I have all income levels at all ages. And so the best I can do is to just make sure that I have a range of ages and a range of incomes. maybe create some scatter plots and see if there are any holes in my data collection. If age versus income doesn't seem to show that I have a good coverage of that space, then I might want to collect more data. So the solution to this problem is collecting more data to make sure we have a representative sample.